What if I told you history? Well, it isn't what we think it is. That it's not just some chaotic jumble of random events, but an actual script, a meticulously written program that's been running for centuries, hidden right out in the open. Today, we're not just going to read history. No, we're going to decompile. Okay, take a look at this. It's just a wall of names, right? This is the official story of the Middle Ages, a long, messy list of kings. On the surface, it's just raw data, a seemingly random sequence of rulers. This is what they want us to see. But you know, inside all that noise, what if there's a signal, a hidden pattern? So, you know how it works when you're trying to crack a code, right? You don't just go after the whole system at once. You find one piece, one repeatable function, a subroutine, and you pull it apart. And that's exactly what we're going to do. We're targeting a specific 400-year chunk of historical data, our subroutine, running from the year 911 to 1313.
And here it is, the succession of Roman-German kings for that period. Looks perfectly normal, doesn't it? Like something you just skim over in a history textbook. Totally unremarkable. But right here, this is where we found the first glitch in the matrix.
But see, when you stop just reading it and start scanning it, when you run a diagnostic on this data, something else pops out, a pattern. Just look at the names Conrad and Henry. They aren't appearing randomly at all. They're acting like bookends for these specific sequences, and they repeat with a kind of precision that it defies coincidence. This isn't history, it's an algorithm.
We can actually write this out, define the pattern. Let's call it the core algorithm, X, Y, N, Y. It's pretty simple, really. X is the first king in the sequence. In our case, that's Conrad. Y is the second king, but he's also the last king of that same sequence. That's Henry. And the N? That's just the variable, the number of other kings squished in the middle.
Now watch this. This is the wild part. The code executes perfectly 4 times in a row. The first sequence has 3 kings in the middle. The next one, 4 kings, then 5, then 6. That variable, the N, it increments by exactly 1 every single time the loop runs. That's a recursive function. That is deliberate. That is programming.
Okay, so finding one pattern, maybe that's a fluke, right? A crazy coincidence. But if this is a real algorithm baked into the system, you'd expect to find it somewhere else in the historical source code. So that's what we did. We ran a search looking at the periods before and after that first 400-year block.
And what do you know? There it is, the exact same core algorithm, X, Y, N, Y, was running in the period right before the one we just looked at. The only difference? The input variables. The program just swapped Conrad for Charles and Henry for Louis. The underlying logic, the operating system itself, is identical. So when you zoom out and look at the bigger picture, you realize this isn't just some little glitch. It's the entire foundation for more than 700 years of European history. You have 3 massive blocks of time, each one running the same recursive algorithm, just with different names swapped in as variables. This is a system. All right, so we've decompiled the individual functions. Now it's time to see the whole program. Let's look at the full system architecture. What happens when you put all these pieces of code together?
And I gotta tell you, the structure of this program, this grand design that's been hiding for centuries, it's even more shocking than the code itself.
And this says it all. It's a perfectly symmetrical structure. I mean, look at it. This isn't just a linear script. It's like a beautiful, balanced piece of architecture. 7 of those recursive loops we found, all stacked in perfect, mirrored order around a central axis. There's just no way that is the result of chance. That is intelligent design.
So the crucial point is this number, 356. From the start of the system, it takes exactly 356 years to reach the center point. And from that center point, it takes another 356 years to get to the end of the system. That's perfect, undeniable symmetry.
Okay, so a design this intricate, it has to have a designer, right? An architect, a coder. This was not an accident. Which brings us to the final and most important question of all. Did the coder leave a signature? Can we find them in the data?
Check this out. Look at the absolute beginning and end of the entire system, the outer frame. It begins with Charles Martel and Pippin the Short. It ends with Maximilian the Greatest and Charles V, the Short and the Greatest. These aren't just names, they're opposites. They're like comments in the code, a little artistic signature left by the creator to frame their masterpiece.
So, when was this code actually written?
Well, that final piece of the outer frame, Charles V, he reigned from 1520 to 1556. This strongly suggests that the entire 700-year history that supposedly came before him wasn't actually compiled, wasn't finalized until his reign. The source material is explicit on this. This system, this perfectly structured history, was very likely designed, written, and put into place during the 16th century. Now, think about what that means. It means centuries of the Middle Ages may not have been lived, but were actually engineered retroactively, written into existence long after they supposedly happened.
And that leaves us with one final, pretty unsettling question. We found the source code for the Middle Ages. We've seen what looks like the author's signature. And it proves that our reality can be scripted. So, if history was coded once, who's writing the code now?